So we're going to be looking at more about domain and range, basically. Okay. So domain range review, we did talk about this during our warm-up. The domain is a set of inputs. Think of it as like just a bag of numbers. And those are things that are allowed to input into your relation. The range is when you put in that input, you turn some handle, right, turn the crank, something pops out, that's its output. So for this particular relation, being a set of ordered pairs, what is the domain? What's the domain, Piyush?
3, -1, 6, -6, sorry, 1, 4.
Okay. And why do I make these little squiggles here?
Because that's like the relation.
The curly brackets represent what? A set. What? Yeah. So the curly brackets say you have a set, a collection of these numbers. Now what's the range? Yeah, what's the range? These are the outputs. And please be careful. When I write these down, I could write them in any order I want. I could have written them in maybe numeric order. It does not imply any sort of order here between these two. These are not mapping. This is the mapping in the table. This is not being mapped here. You can write them in any order you want. Is this particular relation a function?
Yes.
Why?
Every input has one output.
Oh, that's music to my ears here. Every input is one and only one output. All right, here's another one. This is example B. Domain, set of inputs, range, set of outputs. Now looking at this thing, ignore these little dashed lines here. They're just to help you kind of see what the points are. What's the domain of this particular relation here? What's the domain called?
You have -1.
-1? Yeah.
And you have +6.
1, 2, 3, 4, 5, 6. Okay.
And then you have -2.
-1, -2. So tell me how you found that. How'd you do that?
All of the domains are the x values.
So you went this and you said, gee, what is the coordinates of this point here? It's -2 something, right? For domain, I wasn't worried about the y so much. This one, it's -1 something, and this one, it's 6 something, right?
Yeah.
Got to find the range. I care about that something, right?
Yeah.
So what's the y value of this guy?
30. -3.
-3. What's the y value of this guy?
-5.
5? I can put 5 down. And what's the y value here?
1.
So what's my range?
It's -5.
What is it? Go ahead, just tell me.
-3, 5, and 1.
Right? And again, this order, we're not applying a mapping here. I could have written this as -3, 1, 5, right? And it doesn't apply an ordering here, a mapping. Is this thing a function?
Yes.
See, because every input has one and only one output. If I were to add this value, what happens to my domain? Does my domain change? No? Why not? I just added a point. Well, why does it or doesn't it?
No.
It does. So what would be the next thing I have to put in the domain? It's already in there. Right? Do I have to say it twice?
No.
What are possible inputs? 6. It just so happens if I put this 6 here, do I get a new range value?
Yes.
What about, okay, I'm going to put it right here. Okay, so do I have a new range value now? Still, no. So the domain and range are not affected. Is it a function? I heard it over here. Not a function. Why?
Because you have my other swing so
Input 6 now has more than one output, so it's no longer a function if I add that point. Adding a point doesn't necessarily change your domain or range. All right. Now I'm looking at a mapping diagram. This is example C here. What's the domain on this thing? Ryan M, yeah, what?
B,
Yeah. Right, so these are always my inputs over here. And then what are my outputs? Yeah, Matthew?
0, -1,
Right, is this a function?
yeah.
Right, you can look at the arrows. As long as there's only one arrow coming out, fine. Now if I do this, is it a function? No. Does it change my domain or range?
It changes your range.
It does? How does it change my range?
Yeah, it changes the range.
How does it change the range?
No, it doesn't.
Does it or doesn't it? No. Yes, no.
Maybe so. No.
Think of the ordered pair that we just added. We added -2, -2. Is -2 in my domain already?
Yes.
Is -2 in my range already? Yeah, I don't need to change it. Alrighty, let's see what we got here. Let's see, what's the domain here?
Negative
Yeah,
1.
let's just shush. Gigi, what is it?
-1, 5, 2.3,
Oh, so on the left have things that aren't integers?
Yes.
Sure. What's the range?
9,
Yeah.
7.
Oh, awesome. She didn't say 9, right? Because 9's already in there. I don't have to say it again. It's in there. Is it a function? Don't say it again. No, it's not. No, don't say it again. Yes. Yes. Well, now we'll pay attention. Okay. Now I put a little extra. This one's not in your it's not in your notes here. So just look up here. I just kind of threw this one in here. I'm giving you the domain, and I'm giving you a rule. Can you find the range? Then y is -x plus 10. Matthew, you want to take a chance at this?
11. What? 10,
Wow, what magic is this? How'd you come up with these numbers? Look at it, and he did this in his head. He said if you plug a -1 in here and you make it negative, it becomes a +1. 1 plus 10, 11. Very impressive. If you put a 0 in, you get 0 plus 10. If you put a 2 in, -2 plus 10, 8. If you put a 7 in, -7 plus. Beautiful job there. Very, very good. Is it a function? Matthew, is this a function?
Good job.
Every input has one and only one output. Awesome. Okay.
Do you even have that?
You don't. I just told you you don't have it.
Oh.
I did say that, right?
Yes.
Okay.
Like 2 times.
Okay, I thought. All right, now, so domain and range. So far, we've been only looking at what we call discrete domains, meaning countable points. I can see what all the domain values are. Now, what if they're not countable? What if it has an infinite number of points in the domain? Okay. These are called continuous relations. We're going to be using inequality symbols to talk about domain. So this example here, it's towards the bottom. I hope everybody is really paying close attention.
Yep.
I feel like not everybody is. So please pay attention to this. I'm on the bottom of page 1, example A. So look at this thing. Now, I have little points here. Did you ever see these little points, or did you always see them with arrows?
Arrows.
Also little points. What do you think these points mean? What does that mean, Ryan? It's a line segment. Awesome. So it just stops, right? Very nice. So what's the domain of what are my inputs into this particular, well, first of all, is it a function? Let's answer that question first. Function?
Yes.
Every input does have one and only one output. I can use the vertical line test to see that. So what's my domain? What do you think?
It would be
-4, -2 through. What does that mean? I'm not sure I know what that means. What do you think? Anything between or equal to, I like that you said that, or equal to, right, -4 and 4. Does that describe it? Yes. Because if you're thinking, and we're used to thinking in integer values, it's -4, -3, -2, -1, 0, 1, 2, 3, 4. Now if you're thinking that way, we're used to thinking that way. But what about a half? And what about 0.35? And what about 0.29997? Right? How many x values are here? an infinite number of x values in my domain. So an infinite number, how do I write every one of these possible values?
Side with it.
I can't. How long would I have to be here writing numbers?
Maybe
Forever. And it's impossible, right? I couldn't.
I just have to wait again.
So what we do now is we have a mathematical way of doing exactly what Noah said. He said it's anything between -4 and 4, including -4 and 4. So here's how that works. All right, if you want to say between two numbers, you say you're going to have an x value, and you say what's the smallest number it could be? -4, right? You're going to put it here. You're going to put this symbol here. What's the biggest value it can be?
4.
4.
What?
So you put the small, it's like the number line, right? The number line has a small number here and the big number here. So you do that, and then these are number lines, right? Aren't the smaller numbers here? So -4 will be less than whatever you have here, which will be less than 4 as well. Always going to be less than. Smaller number on the left, bigger number on the right, with your x in the middle. This says x is between -4 and 4 by putting these little symbols here. What does that mean? What does that mean? Equal to, right? So is -4 a possibility?
Yes.
Yes. Is 4 a possibility? Uh-huh. Yeah. So the domain is any number between -4 and 4, including it. Now what about the range? Now range are y values, right? So let's say if I put 2 in as my input, what's my output? Up here, right? I think that's a 1. So you see how you find your outputs? You gotta look over here. Okay, so what about if that was -2? What's the output? Probably -1. I think that's what this one is. So I'm basically looking at what are my inputs for? What's my output? So 2. Right? So does that mean my only outputs are -1, 2, -1, 2? Or is it everything in between? So, and included. How do I write? I want all the numbers between -2 and 2, including -2 and 2. What do you think, Cole?
You do negative,
Yeah?
and then the greater than is like, and then you do.
Less than. Always less than.
Oh, yeah, that's
And these are y's, right? Range is y.
yeah.
So this says all the numbers between -4 and 4, including them. That's your domain. And all the values, and included, -2 and 2, right in between and included. Makes sense or not make sense?
Yeah.
Yeah? All right, let's try another example here. Now this one has an open circle. What do you think that means? When we looked at inequalities, you did this last year. What did this mean if you had an inequality like this? What did that mean? What does that mean, Dan? What?
Oh, wait, if it's
This one, right here.
all right, right there.
Yeah.
Would be greater than.
Right. Now, it's a hole, right? If I filled in the hole, what happens? It means the same thing here. This is what we call a hole in the graph. It means that for this input too, there is no output. So we make a hole in the graph. So if I'm looking at now domain, and this is continuous, right? I can't just say it's -2, 0, and not 2, but -2, right? I want everything in between. How do I describe that in a domain? What do you think?
What we do kind of same thing as the last
Yeah.
time.
So what do you do?
Begin -2,
Yeah.
and then greater than equals to.
Always less than.
Or, yeah,
Always.
less than equal to.
Okay.
And then x, and then less than equal to less to.
Now, why did I not put it in whole over here? Because what does this whole mean? It's just like when I had an inequality like this. Why do I make this an x bigger than 1 and not equal to? Right, we did this last year, right?
Yeah.
Why did we tell, because they said, if it's a hole, don't put the little thing under it, right? Why? Why?
Because, if you're not having that one, you don't know what it is.
It's just not part of the graph. There is no value here. If for input 2, I don't have an output. It's not part not part of the domain, right? So how do I say don't include it? I say is two less than two? Just if you put an x of two here, is two less than two? No. So two does not belong in this description. This is the description of numbers. It's saying all the numbers between -2 and 2, including -2, but not including 2. Everything in between with -2, but not 2. That's what this means. So because there's a hole in this graph, 2 is not in the domain. I don't see a y value for it. Yeah. Yes?
So it always has to be a less than.
It's always going to be a less than, because think about it, your smaller number's always here. It's
Uh,
always going to be smaller than the bigger number. Okay? Now let's think about range. Range are your y values. That's looking up and down. So what is the values that your y's can be? Yes, sir. Ryan.
0 is less than, or equal to y, and is less than or equal to
Awesome. Now, why were these equals? I love how you thought about it. Are they equals? Are they not equals? Why did you make them equals?
because there's a number 2 and a number.
Yeah, so if you go to 0, kind of my limit here, right? I see it, it's a nice hard value there. If you go up to 4, sure there's a hole here, but look over here. So 4 is in my range for this value, for -2. So for that point, 4 works. So yeah, wow, that was a lot of work. That's awesome. Yes.
So, like, the reason that you put the x or y in the middle is basically saying, like, x is greater than or equal to -2 and
Uh-huh.
less than or
That's
equal
exactly what it means. It's like writing two things. It's like saying x is bigger than or -2, and at the same time, x is also less than 2. Y is bigger than or equal to 0, and at the same time, it's less than 4. It's between these numbers. In this case, it also includes less than. Oh, we didn't even answer the question. Is this a function?
yes. Yeah.
Who says no? Right? Every input, look at this input, one output, this input, one output. Every input, I'm only seeing one output. Awesome. Okay, this is kind of tough stuff here. Now this one's a little different. Now I don't know if you can see there's an arrow here. Ooh. So think about what are valid inputs. Now let's do it. Is it a function? Let's answer that first. What is a function? Every input has one and only one output. Input 1, you can only go to one place. Input 3, 2.5, right? So what are valid inputs into this step? What do you think then? One is a valid one, okay. What else?
4.
4 works. Now what does this arrow mean?
Goes on.
Ever and ever and ever and ever. So I'm over here, over at 100, say? Is there an output that works? Yeah? Okay, what about over here? This is like a hard endpoint, right? How about at -1? See anything? No? Is -1 part of your domain? No? What's the first thing that's going to be part of your domain? What about 0? Right, look at 0. Now, right, for domain you're looking this way. At input 0, I do have an output. So it looks to me now in words, the domain is x is 0 or bigger, isn't it? Is that our domain? Because think about this. Go over to 1,000,000. You go up eventually. Will you get to a y value? Yeah. So how do you write x is 0 or bigger using mathematical notation? How do you write that?
0 is less than or equal to x is less than.
Oh, you have to do it that way. You could do it like that. Well, and not less than or equal to. And remember, infinity is not a number. So this says x is a number 0 or big, 0 or bigger than 0 all the way up to infinity. What's an easier way to say that? This is not incorrect. That is correct. What's another way to say that? I'm doing it. X bigger than or equal to 0. Does that kind of say the same thing?
Yep.
Does it?
Yes.
Yeah.
So you can say it that way. This is not incorrect. If you say it that way, that's okay too. Now think about our range now. What are valid outputs? And this is sometimes a little trickier now. You kind of turn your head a little bit now. I'm not looking at this anymore. So anything here, do you see any outputs between 0 and 1? I don't see anything. I get to one, I see something, right? Right, here's an output. Now if I keep going, you see outputs? If I go all the way up to 100. So what do you think the range is gonna be for this? Ryan, what do you think? Y, right, because I'm working with the Y, is bigger than or equal to 1. Awesome. Does this make sense?
This Grieser, what is
Connor, wake it up. What?
What does it say?
What does what say?
It says like 0 is.
You could say x is between and includes 0, but it's smaller than infinity. Is that the same as saying x is bigger than or equal to 0?
So you can say that?
You could? Well, let's keep it simple. Do you ever hear this saying? Keep it simple, sweetheart. Right? That doesn't always mean that. If we can keep it simpler, I think we'll remember it. Okay. Who's kind of like, what are you doing? I don't get this. Anybody there like, what? We lost here?
Randy doesn't know.
We're confused about this one? Think about the arrow. Let me get rid of some of those drawings here. An arrow means goes on forever and ever. So inputs, do you see any inputs passed here on this side? A lot of inputs here, right? What are they? Can it be 0? Can it be like 0.1? Can it be 0.001? Can it be all the way up here at 100? Can it be at 5 million? Is there an upper limit on what the domain can do?
No.
But there's a lower limit, right?
Yes.
That's what this says, x bigger than or equal to 0. Now the range, I'm looking up this way. I'm looking for, where do I see a line when I travel this way? I see no, oops, I get here. So 1 is in my range. And then look, there's all kinds of stuff. And this arrow says, if I go all the way up to 1 million, and I look over, will I eventually see something?
Yeah.
So my range is y is bigger than 1, or equal to 1. What if this had been an open circle, a hole? Oh, what would that do to my domain?
We'll make it make it 0.
X bigger than 0, but not including 0. And y bigger than 1, but not including 1. So whether this is a hole or a filled-in hole matters. Let's see, let's look at another example here. Oh, no. Oh, well, first of all, is this thing a function? Let's answer that question first.
Yes.
It is a function. Every input does have one and only one output. In words now, what can we say about the domain valid inputs? Noticing I've got arrows here. What do you think?
X is greater than infinity.
Ooh, it's greater than, well, I can't be greater than infinity. But do you know there's something called negative infinity? Yeah. It's saying going to infinity in that direction. Positive infinity is going to infinity in that direction. So you're saying x is between negative infinity and infinity. Wow! Look at this girl. Whoa! Correct. Now, is there another way to say in English, what is that? That's every number. Every number. And we use the real number system. Our domain are all the real numbers. All real numbers is another way to say that in words. I like the way she said it here, though. That is cool. Yeah.
Since there's like an infinity to the left and right, is
Yeah.
there a middle infinity?
Is there a middle infinity? Well, it depends what dimension we're going. If you want to go to the third dimension, we can get another infinity going.
What is 4?
Yeah. Now, well, what about up and down? That's a great question, Ryan. Up and down, do we have infinities?
No. Yeah.
Where's positive infinity on the y-axis?
Positive infinity.
Where's it going to be? All the way up here, right?
Yeah.
And where's negative infinity?
So there's no
Down,
positive infinity, but there's negative.
Well, that's positive.
All
This is
the-
saying the positive numbers go up here, the negatives go here. What is my range? Right. Y values. Now you're looking up and down, up and down. What do you think, Ryan?
Negative
Always less than, there's never a greater than infinity, because we never get there. Y, okay. Yeah, and then what, where do I go to? How high can I go? There's stuff, I see stuff, see stuff, see stuff, see, oh, no stuff. Two. Less than or equal to, which one? Do I need an equal here? Can it be two? Can it be two? Doesn't that imply that if it's less than or equal to 2, I'm going down to negative infinity?
Yes.
Did you say that? But this is cool that you get this. That's really awesome. It was so, who's kind of like, you know what? I'm tracking. Everybody got it.
Randy.
Who's like, I don't know what you're talking about.
Randy, Randy.
I'm lost. Okay, yeah, raise your hand if you're lost here. Basically what you do is you define domain, you travel along here, notice that this is forever. And you say, what are valid inputs? Well, I can see clearly 0 is 1, 1, negative 1. When I get out here to 10, will there be an output? Yeah, because you have to picture this going forever. If I get out to 100, there going to be an output somewhere? Yep. I go out to 1,000,000. There will be. How about on the other side? Negative 10, eventually, because this keeps going. So any number you want works for the domain. Now the range, on the other hand, you're looking this way. And you're basically saying, where do I see stuff? Nothing, 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 until I get to 2. And when I get below 2, there's more stuff because I can see the function. So y less than or equal to 2 is the range. All real numbers in the domain. All right, let's keep going here. Because now we're going to learn the notation for this called set builder notation. Because remember, shush, not hard. I can't write down every single value of the domain, and I want to be in a set. So it's a way of automatically kind of generating numbers, kind of. So we have to use set notation because domain and range are sets. You must use curly brackets. Who heard that? How do you make them? Can you make these? They're curly brackets. How do you make them? They look like mustaches. I always think they look like a profile. Forehead, nose, chin. Or go the other way. Person looking the other way. Forehead, nose, chin. It's like a profile. And that would be the eyes. Okay? So you're going to have to practice making these little guys. So you make them, shush. This here, see there's a little line here separating it? This condition is the thing that we've been doing. That is this thing. And that is this thing. So once you figure out the inequality that works, that goes here. This part here is like a declaration. And it's where you say, okay, I'm talking about x. What is x? What number system does x belong to? This says x, this little funny e thing, the x up an epsilon, it means x is an element of the real numbers. The fancy R means real numbers. Such that any x in the real number, if it is bigger than 3, it's in my set. So what are the numbers that this is building? Well, it's got 3.1, it's got 4, it's got a million. What else is going to be in this set? X bigger than 3. All the numbers bigger than 3. Right? So this is set builder notation. So the things that we have to be careful of, what if I want all the real numbers? Like for this one, all the real numbers are my domain. What's the condition for that? You say, well, x is a real number such that x is in the set. You just say x. Think about that. When do I include the real numbers here? All the time. What numbers do I include here? Only the ones bigger than 3. So let's kind of revisit this. Now, let's go back. The domain here, you already told me this domain. You said it's between and including -4 and 4. Want to see how easy it is to put this in set builder notation? You'll watch it.
Okay.
Right, you on the back? Write this down on the back here. First of all, make your brackets. Notice how I left a little room here? Okay, put it in brackets. For our purposes, we're only using real numbers. So x is an element of the real numbers. This line means such that x is a real number such that x is between and includes -4 and 4. Okay, the range on this, you told me it was between -2 and 2 and including those values, right? So how do I make it set builder notation? You add your curly bracket, and you say, now I'm working with this variable y. What kind of number is y? Y is a real number, such that it is between and includes -2 and 2. That's all you have to do to make set builder notation.
Oh, really?
That's all you have to do to make, why it's confusing.
I don't know.
Make 2 little brackets, Tell me what kind of number y is. It's a real number. Okay.
But will there be differences?
Yes, there can be. Now, not for us. When you go up in that, what if I said y is an element of, do you know what this thing even means? See?
Non-inclusive.
And if no, this, a fancy G means integer. So if y is an integer, that describes a different set. That's going to be -2, -1, 0, and 1, and 2. Integers only. Is that the same as this set? What's in this set? All this plus everything in between. -half. So this is coming in later years. So we need to understand the notation now. Y is a real number such that y is between and includes -2 and 2. That includes the fractions, right? Includes all the decimal numbers, all that stuff. Now to further, I think it simplifies it. You might think it's complicated things. This part here, if you leave it out, if you just say this, it assumes you mean real number. So this and this describe the same set of numbers. Are elements of the reals. Y is an element of the reals such that this also says y is a real number such that. It just assumes if you don't say it's an integer or something else, it's a real number. Let's do another example here. Again, we've done these, right? We've done the hard part. You know what the hard part is? Figuring out the inequality. Here's what you told me. You said x, it's between and includes -2, but it's less than 2, not including 2, right? Show me. Isn't it? So how do I turn it into set builder notation? Curly brackets, x, and a bar.
Why just that?
Wait, why is it different then?
It's the same. I could say this, or I could not. If you leave out the element of reals, it assumes you mean element of reals. It's optional.
Oh, this, okay.
That's what that means.
Okay, that makes
When I
sense.
said you could leave it out. Now this one, our range, it's any number between 0 and 4, including 0 and 4. So that was this. How do I turn it into set builder notation? Add some brackets, put a y, and this. You can say this, or you can say this. They are both correct if you put elements of the real. That's it. That's all you have to do. That's all you have to do. It's not that much. All right, this one, remember this one? This one, our domain was x is greater than or equal to 0. Because that was going this way. Bracket, bracket, x. Done. This one, our range. Remember the range? Y bigger than or equal to 1. Because here's 1, it's a little bigger. Put it in the brackets. Done. Set builder notation. You want to be fancy? Put in the elements of reals. Either way is correct. Right, everything's in there. All you have to do is just put the brackets in.
Wait, so you could just put X, you could put X
The hard part is this, coming up with the inequality. Hard part, right? The other part is put it in brackets to okay, this one, that's all I did. We figured this out already. I'm just putting it in the notation. Now this one was a little trickier. I'm going to start with the range. Y less than 2. Put in I need it to be a set. Y is a real number such that y is less than 2. Now we have a little trouble when it's all real numbers. So I know x is a real number, right? What's the condition that I want it to be in the set? Any x works, right?
Yeah.
So any x you pick from the real numbers, what's the condition on it? There is no condition. Take it. It's in the set. So any x that you pick as a real number is going to be in the set. That says all real numbers. Yes.
So if it was all real numbers, could you just do X such as,
Yes. This. Yes. That means all real numbers. X is a real number such that that x will be in the set. Any real number you want will be in the set because look at my domain. Any x works. Yeah, I know. We're just a notation. So don't get afraid. Notation. But we're afraid. Don't be afraid.
But this seems
Who's afraid?
It seems way too
Okay,
hard.
you All right. Okay, you try. We're going to do a couple now, so we'll put it all together, okay, shall we? First of all, do the function, not a function. Is that a function?
Yes. No, it's not.
Why not?
Because
Every input has one and only one output. Look at all the inputs. I don't see any with overlapping stuff here.
oh, never mind.
Domain. That's going this way. What is the domain? Do it in words first. Don't worry about what the inequality is. What's the domain here? What are valid inputs? What are valid inputs?
Anything that
Okay, so anything between what?
anything negative to negative 3.
Anything between -3 and 3. And then do I include -3 under 3?
You include
Yes.
3, but you don't include
Yes. So we're going to include 3. Now why is that? Because this is a closed hole. This is an open hole. -3 not part of the domain. Now how do you write that as an inequality? How do you write that as an inequality?
3,
You start with a small number.
negative 3 is less than and equal to x.
No equal to. Why no equal to?
Oh, because
I got a hole there, so it's not going to be -3. It's a hole. You'll fall right in. Right? I'm not going to use -3. And then this one's a less than equal to because 3 is valid. It's filled in holes. You can go there. We're not going to fall in. Okay, this is kind of the hard part. You know what the easy part is? Add a bracket. X is a real number such that this condition has to be
you're
true.
supposed to do that for domain.
That's domain. Now what's the range? Now Y values are going this way, going up and down. So what are the Y values here? What are the valid outputs? Okay, tell me in words here, Ryan.
It's, between -3,
-3, and then stuff here, stuff here, stuff here, stuff here. To where? +3. Do I include them or not include them? Build in hole, right? Build in hole, we include that. Big hole, you're gonna fall in, so you don't want to include that one. So now I'm looking at the Y's. So Y looks like it's less than or equal to -3, but only less than 3 because I don't want to fall in. This is the hard part. Then I say, okay, let me just put it in set field notation. I'm gonna add my brackets. I'm gonna put a Y here and put a line there. That's what we do.
That's the hard part.
That's the easy part. Yeah, the hard part is coming up with the inequality. It's not that hard. Yeah.
I don't like that why you do like the not sure equal to
Because that's how we say it's between them. Y is bigger than or equal to -3. That's true, right?
yeah.
But it doesn't go forever, right? I have to stop at 3. So that says it's between those numbers. Now I put a less than here because I can't actually be 3 because look, when you look over, you'll fall in the graph. So I can't, that's a hole, you'll fall right through. So I can't be 3, that's why it's just, there's no equal here. But if I go down here, I can be -3, it's still in hole. Now that's X. Let's look at X now. -3 is not an input because I'll fall in the hole, but 3 is an input. So for domain, you go this way, for range, you go that way. Let's try another one here. Is this a function?
Yes.
No, why not? Not a function. Because look at that. Look at -2. There exists an input with more than one output. Look at all the outputs of -2. Not, but I can still have a domain, right? So going this way, where are the inputs into this relation? Do you see anything happening here? Something? What do you think, Danny?
for X, -2,
Yeah?
and like this,
And it keeps going, right?
yeah.
So my x's are bigger than -2 or they be -2?
Yes. No.
Yeah, sure. And then here's an x of -2. I got all kinds of x's of -2. So again, that's kind of the hard part. Turn it into set builder notation. Boom, done. Now what about my range? Look at this range, up and down here. This goes forever. This goes forever. What's my range? Like I see stuff. Where do I see stuff? Yeah, where do I see stuff, Ryan? You say it. What do you think it is? Well, what about over here? What about y's when I'm not at -2? Think about being at -10. Do I still have a y value? What if I'm at 10? Yeah, what do you think? your range. This arrow, you gotta picture it going forever. So no matter what Y you pick, move over, you're gonna hit something. Now, all real numbers, now we have to remember how to say that in, set builder notation. So Y is a real number such that Y is in the set. Any real number is gonna be in the set. This means all real numbers. Okay, all real numbers. Yeah? Anybody following it all?
I'm following you, I don't get it.
I follow you.
Okay. Alrighty, let's try this guy. Oh, you write it down. See, you try, you figure it out. Oh, what?
Got domain.
Alright, first of all, is it a function?
Yes.
Yeah, never mind.
What's the domain then?
I said -8 is less than or equal to x less than oh.
Oh, look how fast he did that. He said, look, I'm going this way. -8 has a value. I don't see anything past that. Stuff, nothing past 6. Pull over here. So I'm going to make it less than. Now, how are you going to turn this into set builder notation? Add your brackets, add your s, put a bar in, set builder notation. Somebody else, range. Somebody else, what do you think, Ryan? Go this way here. Always less than. Now you're looking at this -8, right? Now we're going this way.
Less than Y. Less than 6.
Awesome. Let's turn it into set builder notation. Okay, look this way, look that way. Last good example I have here, is this a function?
Yes. Yes.
Function?
Yes.
Yes. How come, Cole?
Because you know.
I'm gonna use that little straight line vertical test.
Yeah,
Every
that's
input
what it says.
has one and only one. Remember, don't give me that as your reason. Every input has one and only one output. Think about the domain. What are valid inputs? There's arrows here. There's arrows here. No, but what are my valid inputs? All real numbers. Excellent, right? ADS. Picture this going forever. So how do I write that in set builder notation? Do you remember, Noah?
Yeah.
Such that X is in the set. Any X that's a real number, you can put this in or not put that in. Now, yeah.
For B?
Yeah.
Would it just switch it?
For B?
Yeah, for B.
Yeah, it's turned around, you picture that. Kind of. What is my range now going up and down? Right, I'm looking, I see nothing, whoops. Something. And where are all my range values? Where are they gonna be, Noah?
Y is less than or
Awesome. That's awesome, right? Because nothing until I get to 4 and then things smaller than 4. Look at that, you go to -5, you're gonna find stuff. Go to -10, you're gonna eventually find stuff. Go to -1,000, you'll find stuff. Now let's turn it into set builder notation, put in your brackets. Y is a real number such that Y is less than or equal to 4. Who kind of is like, you know what? Well, click it on a little bit.
I got it.
All right, now if you're not that person clicking on, you may need to watch it a couple of times. I'll put this up tonight, this little video of what we just did.